Welcome back, everyone, to This Explainer. If you're prepping for a competitive exam, or honestly just looking to completely upgrade your cognitive skills, you are in exactly the right place. Today, we're building your ultimate problem-solving toolkit. We are going to construct a mental arsenal packed with the logic, patterns, and math cheat codes you need to decode complex problems in literally seconds rather than minutes.
Okay, let's dive right into today's agenda. We're going to start with the foundations of logic, move on to cracking patterns and codes. Then we'll tackle mapping family relationships, and finally, wrap the whole thing up with mathematical aptitude shortcuts. Let's kick things off with Section 1, the foundations of logic, or how to build your deductive and inductive muscles.
So the absolutely crucial point here is understanding the direction your brain is traveling when you're evaluating information. On the left, we've got deductive reasoning. Think of this as a top-down approach. You start with a big, general rule and apply it to a very specific case. Now, if your starting rules, your premises, are true, deductive reasoning literally guarantees the truth of your conclusion. But on the right, we have inductive reasoning. This is the exact opposite. It's a bottom-up approach. Here, you're observing specific, particular instances and building upward to form a general rule. Unlike deduction, inductive reasoning doesn't guarantee truth. It just establishes probability based on what you've actually observed.
And this brilliantly illustrates how these primary reasoning types compare, and, introduces a fantastic third player into the mix, abductive reasoning. Look at the examples we've laid out. For deductive, we see the classic, all humans are mortal, Socrates is human, therefore Socrates is mortal. Boom, it's certain. For inductive, it's more like, every swan observed so far is white, therefore all swans are white. It's highly probable, sure, but a single black swan could totally invalidate it. And then we have abductive reasoning. Think of this as your inner detective. It's cause-seeking. You observe that, hey, the ground is wet, and you form the most plausible hypothesis, it likely rained last night. It's not guaranteed, it's not a broad rule, but it is for sure the best explanation for an incomplete observation.
Moving right along to Section 2, cracking patterns and codes. This is all about deciphering series and secret rules.
Whenever you're faced with a number series, your brain should immediately start scanning for these specific changes. Is it an arithmetic difference, where they're just adding or subtracting the exact same number? Or perhaps a geometric progression, multiplying or dividing to scale the numbers up really fast? Keep an eye out for square or cube patterns, where the numbers relate to squares or cubes, maybe plus or minus a constant. Sometimes they're going to try to trick you with an alternate or mixed series. This is literally two different series happening simultaneously, woven together like a puzzle. And hey, don't forget the Fibonacci type series, where each term is just the sum of the preceding ones. The real trick here? Never look at the numbers as isolated digits. Instead, see them as steps in a highly structured dance. Now, what's really interesting about this slide is that these aren't just random multiples of 5, 10, 15, 20, 25. These numbers represent the ultimate cheat code for letter series, the EJOTY mnemonic. E is the 5th letter, J is the 10th, O is the 15th, T is the 20th, and Y is the 25th. If you memorize EJOTY, you instantly have anchor points across the entire alphabet. That means you never have to sit there counting on your fingers from A just to find out what numerical position the letter W holds. You just know T is 20, U, V, W, so W has to be 23. It's a real game changer.
Alongside EJOT, you really need to understand reverse pairs, A and Z, B and Y, C and X. The massive shortcut here is that the numerical position of these pairs will literally always sum up to exactly 27. A is 1, Z is 26, total is 27. B is 2, Y is 25, total is 27. You get the idea. If a code requires you to find the reverse of a letter, just subtract its position from 27. Honestly, it saves an incredible amount of mental energy on test day.
So, when they throw coding-decoding questions at you, you've got to know their tricks. They'll usually do one of three things. First, letter-to-letter coding, where they shift letters forward or backward by a fixed offset, like +2 or -1. Second, letter-to-number coding, where they convert letters into those numerical positions we literally just talked about. Or third, substitution coding, where they swap labels entirely, trying to totally confuse you with absurd statements like, if red is called blue and blue is called green. When you see that, don't get distracted. Just blindly follow their defined rules. This actually brings us to a super common trap. How in the world do you trace complex family ties across multiple generations without getting completely lost in a web of, my mother's brother's wife's daughter? Well, that brings us to Section 3, Mapping Family Relationships, where we turn those confusing relatives into simple, logical symbols.
First things first, let's lock down the basic terminology. Paternal simply means related through the father's side. Maternal means related through the mother's side. Establishing exactly which side of the family tree you're climbing is always step one.
Let's move to and see how this builds into a seriously powerful visual system. Because, let's face it, word problems are messy. Symbols are clean. So from now on, males are squares or a plus sign. Females are circles or a minus sign. Siblings from the exact same generation, just connect them with a single horizontal line. What about a married couple? Connect them with a double horizontal line. And to show a generation gap, like a parent down to a child, use a vertical line. By literally sketching these out on scratch paper, the answer practically reveals itself.
Once you've got it all mapped out with your squares and circles, you just translate the visual back into the standard family terms to pick your answer. If your map shows your parent connected by a single horizontal line to another square, well, that's their brother, your uncle. Your siblings' children are your nephews or nieces. And tracing up 2 vertical generation lines, that leads you straight to the grandparents. Using this visual method completely eliminates all that second guessing. All right, let's power through to Section 4, Mathematical Aptitude Shortcuts, giving you the formulas you need for rapid calculation.
Before you even think about calculating anything, you absolutely must understand the core relationship between the variables in your word problem. Is it a direct proportion, meaning as one variable increases, the other increases right along with it, kind of like how buying more apples costs more money? Or is it an inverse proportion, whereas one variable increases, the other decreases, like adding more workers to a job decreases the total time it takes to finish it? Grasping this interaction instantly tells you exactly how to set up your equation. Okay, here is one of my absolute favorite time savers for speed and distance problems. Test makers love to mix units, right? Giving you speed in kilometers per hour, but asking for an answer in meters per second. Please do not do the long math. To convert kilometers per hour to meters per second, just multiply by 5/18. Going the other way, multiply by 18/5. Memorize these fractions, they are totally crucial.
And of course, you've got to have these heavy-hitting formulas chambered and ready to go. If a problem asks for average speed over 2 equal distances at different speeds, let's call them A and B, the formula is just 2AB divided by A plus B. For discount percentage, it's the marked price minus the selling price divided by the marked price, all times 100. And for compound interest, the interest alone is the principal amount multiplied by 1 plus the rate over 100 to the power of time minus the original principal. Honestly, recognizing exactly when to pull these specific formulas out is half the battle. So, let's pull everything together in this master summary matrix, basically your ultimate cheat sheet. We've got the EJOT method for letter series. We've covered relative motion, where opposite directions add speeds and same directions subtract. Notice also that simple interest is just linear growth. It stays constant every single year. But I want you to look at that percentage trick in the second row. X% of Y equals Y% of X. This is an absolute game changer. Think about it. If a test asks you for 16% of 50, that might sound hard to do in your head. But swap it. What is 50% of 16? It's 8, which means 16% of 50 is also 8. Bypassing complex math entirely is what true aptitude looks like.
You now have the logic to reason flawlessly, the keys to decode any series, a visual map for tangled relationships, and the mathematical shortcuts to buy yourself precious time. The toolkit is all yours, so the only question left is, which tool will you use to crack your next test?